Today we are going to discuss about the physical and chemical properties of ethers. Physical and chemical properties of ether. Physical property. Physical properties of ether. Here, the boiling point of ether is less than alcohol. Because in the alcohol, hydrogen bond is there, and ethers there is no hydrogen bond. Slightly hydrogen bond is formed with water. That's what the boiling point of ether is less than alcohols, and ethers are slightly soluble in water because these are forming hydrogen bond with water molecules. Okay. Coming to the chemical properties. Here, basic nature. The first one is basic nature. Basic nature. Here, this is ether molecular formula. Here the two lone pair is there. So according to Lewis acid base theory, electron donors are called base and electron acceptors is called acid. Electron acceptor is called acid. They act as acid, and the lone pair is there. So as they have a lone pair of electrons, they donate lone pair of electron to the adjacent atoms. That's what we call, these are the base, Lewis base. Another example, RMGX. RMGX is a acid electron acceptor. These are the electron donor base. Now reaction with sulfuric acid. Here ether, when we react with ice cold sulfuric acid to gives oxonium salt, it is stable at 0 degree centigrade. Ether, when we react with ice cold sulfuric acid, means ice cold and sulfuric acid to gives ROR plus HSO4 minus. HSO4 minus. Here the screen is not visible. We will wait. This is the oxonium salt. Oxonium salt. So this oxonium salt is stable at 0 degree centigrade. Same ether, when we react to dilute H2SO4, we get alcohol. Here, same ether, when we react with dilute H2SO4 to gives 2 molecules of alcohol. 2 molecules of alcohols. Here, same ether, when we react with concentrated sulfuric acid, we get oxonium salt. Here, same ether, when you react with concentrated sulfuric acid to gives 2RHSO4. Here oxonium salt is obtained here. Once again I am repeating. Here the ether, when you react with ice cold sulfuric acid to gives oxonium salt, this oxonium salt is stable at 0 degree centigrade. And same ether, when we react to dilute H2SO4 to gives 2 molecules of alcohol. And same ether, when we react to con H2SO4 to gives oxonium salt, 2 molecules of oxonium salts. Here another reaction is reaction with hydrogen halide, means HCl, HBr or HI. Here ether, the third reaction, ether, when we react with hydrogen halide plus HI, hydrogen iodide, to gives 1 molecule alcohol and another molecule is alkyl iodide. Alkyl halides. Here the ether, when you react with hydrogen iodide to gives alcohol and alkyl halide. We will see one example. CH3, CH2, O CH3 plus H gives rise CH3 CH2 plus CH3. Here ethyl methyl ether, when we react with hydrogen iodide to gives one molecule ethanol and another molecule is methyl iodide. Here, ethyl methyl ether, when we react with hydrogen iodide to gives one molecule ethanol and another molecule is methyl iodide. Here bigger alkyl converts into alcohol and smaller alkyl chain convert into alkyl halide chain. Okay, now we will see a mechanism here. CH3 CH2O CH3 plus HI gives CH3 CH3 CH2O H CH2 CH3 CH2 OH plus methyl iodide. So this is about the reaction mechanism of ether when you react with hydrogen halide. Okay. Here alkyl ether when you react with hydrogen iodide to gives phenol and methyl iodide. For example, PHOCH3. Methyl phenyl ether when you react with hydrogen iodide to gives screen is not visible. Here P phenol plus methyl iodide. Here same CH3 CH2O CH3. When you react this with excess amount of hydrogen iodide, you get two molecules alkyl iodide obtained, CH3 CH2I plus CH3I. Here when we react this ethyl methyl ether with excess amount of hydrogen iodide to gives ethyl iodide and methyl iodide. Here same phenyl methyl ether when we react with excess amount of hydrogen iodide to gives phenol and methyl iodide. Here next halogenation reaction. Fourth one is halogenation reaction. Here diethyl ether when you react with chlorine in the presence of dark gives alpha dash dichloro diethyl ether, CH3 CHCl O CHCl CH3 alpha dash dichloro diethyl ether. Or same diethyl ether when you react with 10 molecules of chlorine in the presence of light, here it is dark, in the presence of light, you get Cl5 C2O C2Cl5 perchloroether is obtained. Here diethyl ether when you react with chlorine in the presence of dark to gives alpha dash dichloro diethyl ether. Here same diethyl ether when you react with 10 molecules of chlorine in the presence of light to gives perchloroether. Next reaction with PCl5 phosphorus pentachloride, reaction with PCl5 C2H5 C2H5 O C2H5. When you react with PCl5, it gives 2C2H5Cl plus POCl3. Here the diethyl ether, when you react with phosphorus pentachloride, to gives ethyl chloride and POCl3, phosphorus oxychloride. Now coming to the reaction with acetic anhydride. Reaction with acetic anhydride. Acetic anhydride. Here C2H5O C2H5. Acetic anhydride, ACTO, is called acetic anhydride in the presence of zinc chloride. To gives ethyl acetate. To gives ethyl acetate. Here diethyl ether, when you react with acetic anhydride in the presence of zinc chloride, to gives ethyl acetate. Here see ether, when you react with acetyl chloride, reaction with acetyl chloride, reaction with acetyl chloride. Here the ether, when you react with acetyl chloride, to gives ethyl halide and ethyl acetate. Acetyl chloride, the presence of zinc chloride, to give C2H5Cl, ethyl chloride plus CH3COO C2H5, ethyl acetate. So this is about the chemical properties of ethers. Okay, we will meet again next class.